Hello, my name is Mr. Whiteman and I'll be going through in this session reacting mass calculations. The equations I'll be using are on the screen, but in another session I'll be showing you how to use these in addition to some other equations to apply to harder questions, but in this session it will just be reacting mass calculations using the equations as shown. I'll be needing to use the periodic table to work out relative molecular or formula mass, and it's important to know which value you need to use to do this. In this periodic table, as the key shows, I'll need to use the top number. So let's get started. Example 1, calcium oxide is formed when calcium carbonate is heated. What mass of calcium oxide is formed from 50 grams of calcium carbonate? Usually they provide you with an equation in an exam. And to make things easier, I'm going to present my values in a table. You could do this in exam if you wish, but as you grow in confidence, you won't necessarily have to do this. So reading the question, I have 50 grams of calcium carbonate. It's important to know what carbonate resembles. So carbonate refers to CO3 as a set of elements together. And calcium, therefore, being Ca, would mean that this is calcium carbonate. And I have 50 grams of it. I've been asked to work out calcium oxide, which is CaO. And so, using the periodic table, I can work out the MR, which is the relative formula mass in this case, as 100, because the calcium is worth 40, carbon is worth 12, and I've got 3 lots of oxygen, and that gives me 100 as a value. To work out moles, 50 divided by 100, because mass over MR equals moles, mass being 50 and the MR being 100, will give me 0.5 moles of calcium carbonate. The ratio of the equation is the whole number ratio as presented. In this case, it's 1, 1, 1. Therefore, if I had 0.5 moles of calcium carbonate, then I'm also going to have 0.5 moles of calcium oxide. If I had 2 moles of calcium carbonate, then I would have 2 moles of calcium oxide. If I had 3 moles, then I would have 3 moles of calcium oxide as well. And so, because I have 0.5, timesing that by 1, because the ratio is 1 to 1 in the equation, means I'm going to have 0.5 moles of calcium oxide. To work out the mass equals moles times MR. I now have 0.5 moles, and the relative molecular mass of calcium oxide is 56. So 0.5 times 56 will give me a mass of 28 grams. Appreciating that mass cannot be created nor destroyed, then technically I can work out carbon dioxide. So if I have 50 grams as reactants, then 50 take away 28 will present me with CO2. So just to show you that I can work this out either way, so this would be 22 grams. But if I had 0.5 moles of CO2, then the relative molecular mass of CO2 would be 44, because 12 for carbon, 16 times 2 for the 2 oxygens. Half of 44 is 22, and 22 and 28 together gives me 50. But in this question, it's only asking me to work out calcium oxide, and so there's no need to work out CO2, which is why I grayed out the column. Example 2. What mass of oxygen reacts with 46 grams of sodium? So the first example was easy because the ratio of the equation was 1, 1, 1. This ratio is 4, 1, 2. So I've been given a question that says I've got 46 grams of sodium. I've been asked to work out the mass of oxygen. I don't really care about the sodium oxide. Each sodium is 23. Technically it's a relative atomic mass, AR. It's not a molecule, but I'll just use MR probably in future. It's important to note here I haven't times this by 4. There is another method you could use, which is a proportion sum method, but I advise you not to learn this method because throughout chemistry, generally, if you want to take A-level or equivalent, then you need to be able to work in moles. And so I need to know how many moles I have. So to do this, 46 divided by 23 is going to give me 2. If I had 4 sodiums, then that would mean, in terms of moles, if I had 4 moles of sodium, rather, 4 times 23 is going to give me 92 grams as a mass, which I don't have 92 grams, I've only got 46, which is why I haven't times the molar mass by 4, because it doesn't make sense. I've only got 2 moles of sodium. So don't times the MR by the big number. There are other methods in which you do. In this method I am working in moles, and so do not do that. Each sodium is worth 23. So 46 divided by 23 is 2. The ratio is 4 to 1. So if I had 4 moles of sodium, then I'd have 1 mole of oxygen. But I don't have 4, I've got 2. So the difference between 4 and 1 is obviously divided by 4. So 2 divided by 4 will give me 0.5 moles of oxygen. This isn't meaning that I've got my oxygen cut in half. This means that I have half a mole of this. If I had half a dozen eggs, then I have 6 eggs. But the eggs would be whole. So it's important to remember that this is a mole amount, so it's quite a large amount of particles. So half a dozen eggs, half a mole, is a collection of atoms in this case, or molecules. So now that I have the moles of oxygen, I can work out the mass. The periodic table will tell me that the molar mass of molecular oxygen diatomic is 32, so 16 times 2 is 32. So remembering that the little numbers I do use, so I have 2 lots of oxygen, and the little number means I multiply the element immediately before it. So 16 times 2 is 32, and therefore mass is moles times MR. So half of 32 is 16 grams, and that gives me the answer. So the question can get even slightly harder, where the ratio is not simply just double it or triple it. So what mass of aluminium reacts with 10.65 grams of chlorine? So, similarly, I need to work out the MR of each. So chlorine would be, looking at the periodic table, 35.5. It's important you don't round it. So chlorine is 35.5. It's 0.5 for a reason, because it's an average. So don't round it to 36. There are 2 of them. So 35.5 times by 2 is 71. And again, remember, do not times this by 3, because I haven't got 3 moles of chlorine. Mass over MR, so 10.65 divided by 71 will give me the amount in moles, which is 0.15. I haven't even got 3 moles. I've hardly got even 1. So remember, do not times it by the big number. So the ratio is 3 to 2. So you apply the ratio to moles only. So to get 1 part, 0.15 divided by 3, I guess you could visualize to say 15 divided by 3, would give you 5, put the decimal in, so 0.5, and then times that by 2. So divided by 3, because to get 1 part, times it by 2, because there's 2 aluminiums. So effectively 0.15 times 2 over 3 will give me 0.1. Now that I have the moles of aluminium, I can work out the mass. Mass is equal to moles times, in this case, AR, but let's say MR. So 0.1 times 27, put the decimal back in, is 2.7. And that's the answer. Have an exam question now, so feel free to pause the video but I will go through the answer as well. So to give you a chance, you can pause the video now. Okay, I will now go through the answer. Usually in exams they like to present some extra information that is generally unnecessary. Titanium is the transition metal used as pins and plates to support badly broken bones. Great. Titanium is extracted from an ore that contains the mineral titanium oxide. This oxide is converted into titanium chloride. Titanium chloride is heated with sodium to form titanium metal. This reaction takes place in an atmosphere of a noble gas such as oxygen. Woohoo! The equation is 4 sodiums to 1 titanium tetrachloride, TiCl4, to make titanium, and 4 lots of sodium chloride. Calculate the mass of titanium that can be extracted from 570 kilograms of titanium chloride. Sometimes they like to present the information that you need in the question, which is quite handy. So we need to work out what it is we actually need to do. So he's asked us to work out the mass of titanium. Titanium is this. That can be extracted from a mass of titanium chloride, which is this. So these are the only ones we need to focus on. The ratio is 1 to 1. So feel free to just copy this down if you want to do the table method, if it helps. So 1 lot of titanium chloride per making 1 lot of titanium. So because the question involves a mass, I'll write mass on the left-hand side. There's no other information presented other than the relative atomic masses of the elements, so I'm going to have to use the periodic table, as it were, to work out the MR to calculate moles. The mass is 570 kilograms. You should usually convert to grams, but appreciate that you probably wouldn't need to do that in this case, especially when the answer is asking us to be presented in kilograms. So I can just put 570 here. And appreciate though, when I divide by the MR of titanium chloride, and that's going to be 48 for titanium plus 4 lots of 35.5, if I can correct that. 4 lots of 35.5, there we go. And so 48 plus 4 times 35.5 gives me an MR of 190. So 570 divided by 190 is 3. Appreciate that this is technically kilomoles, because if I had in grams, it would be 3,000 moles. The ratio is 1 to 1, so therefore 3 kilomoles to 3 kilomoles, of which the titanium is 48 as a mass number, and mass is moles times MR, and so 48 times by 3 will give me an answer of 144 kilograms. Woohoo! And that's it. If you're feeling more confident, then I would recommend presenting your answer along the lines of this. So, we want to write moles of titanium chloride is equal to 3,000 moles, or 3 kilomoles. The ratio is 1 to 1, so moles of titanium is going to be the same. So I said, might as well keep it as kilomoles. Therefore, the mass of titanium will be 3 times 48, which is 144 kilograms. If you present your work in this way, this should really show working throughout, such as this, then it makes it clear to the examiner what you're referring to, or stick to the table that I had before. Exam question 2. So if you wish to go through this, pause the video Okay, to go through the answer of this, 3 marks for the MR of iron Roman numeral 3 oxide. That Roman numeral means the charge on the iron, not how many ions you have. So that means that the iron is a +3. Using the periodic table, oxygen is in group 6, which means 2 electrons to make 8. So as an ion, each one is worth -2. If each ion is worth +3, that gives you a total of +6 and -6. And so when we write ionic formulae, they need to be balanced out. You need to also remember that this is an ionic lattice, which means you don't actually just have 2 ions and 3 oxygens. You have many ions and many oxide ions in a ratio of 2:3 in a giant ionic lattice. But the empirical formula is just Fe2O3. Gone on a tangent here, but just need to work out the MR just to help you with the understanding of the formulae. There'll be another video on how to work out formulae using the periodic table to help you. So very simply, the little number means of how many you have of the element immediately before it. So 2 lots of iron, therefore that would mean, in this case, using the periodic table, iron is 56. So 56 times 2 plus 16 times 3 will give me a total of 160. And that's apparently 3 marks. Usually that's about 2. Could even be 1. Quite simple that. Calculate the mass of iron produced when 32 grams of iron Roman numeral 3 oxide is completely reduced by aluminium. The reaction is shown in the simple equation. So this question is not a 1-to-1. So it's good to, again, point out what I need to work out. The mass of iron, this is iron, when 32 grams of iron Roman numeral 3 oxide, got a bit tongue-tied there, so that's that one, it's completely reduced by aluminium, which is that. But it's asking us to work out iron, so I don't actually need to care about aluminium or even this. So again, I'm just comparing iron oxide and iron in a ratio that is 1-to-2. So I could just write this down here and present it in a table if that helps. 32 grams of iron oxide. I haven't done a calculation yet, but got 32. And I'm trying to work out the iron. So I'm going to need to use the MR, which I calculated earlier, as 160. I can then use that to work out moles. So 32 divided by 160, because mass divided by MR is moles, will give me 0.2 of a mole. The ratio is 1-to-2. So if I had 1 iron oxide, I'd have 2 ions. If I had 2 iron oxides, I'd have 4 ions, but I don't have 1 or any other number, I have only 0.2. So the ratio is 1-to-2, so times that by 2 would mean I've got 0.4 moles of iron. Each iron has a value of 56. So again, it's important to remember we are not timesing that by the big number, because I don't have 2 moles of iron, I've only got 0.4. So each individual iron is 56, as it were. 0.4 multiplied by 56 will give me the mass. So mass is equal to moles times MR. 0.4 times 56 will give me a mass of 22.4 grams, which is the answer. I hope this has been helpful for you. Please subscribe, and for more chemistry support, please do also write down in the comments.